Hey everyone, and welcome back to another sensational science video. I'm back with another space topic video, this time about star systems. Before we begin, I would just like to say that I am filming and creating these videos using PowerPoint, so if you have any other software that I could use that you think is quite cool and provides very good graphics and all of that kind of stuff, please let me know in the comments below. I will be reading them. Anyway, on with this video. A star system is a group of at least one star and one planet where the planets orbit the star, just like the solar system, which is a star system, obviously. The star is always at the centre of the system. The planets orbit the star and provide heat. There is always a Goldilocks zone in any star system. This is a ring around the star, which is basically an area, not a literal ring, which can provide enough heat to maintain liquid water and at least some microorganisms to live. A planet is a large object usually orbiting a star, but can very rarely lose the orbit and drift off into the unknown depths of space. There are three commonly known types of planets: terrestrial planets like Earth or Mars, gas giants like Jupiter or Saturn, and ice giants like Uranus and Neptune. Gas giants and ice giants usually have a much stronger gravitational pull than the terrestrial planets because they usually have a very dense and very rocky core in the centre which provides this. A star is a massive ball of gas burning up. They are usually formed by nebulae, which are massive gas clouds in space. By the way, nebulae is plural for nebula. A star is actually a ticking time bomb because all stars have an expiry date. This is usually in billions of years. Once that time reaches, a star the size of our Sun, or smaller, will expand into a red giant when the core shrinks, and eventually, when it runs out of gas, the outer layers shed off and the core is the only part that remains. This is a white dwarf. It still has some energy, but when the energy runs out, this usually takes hundreds of billions of years, it turns into a black dwarf, which still does have gravitational energy. With a star that is at least 8 times larger than the Sun, it will show no sign of expiry before the big one happens. It will explode in a massive supernova. Once again, the outer layers will shed off in the explosion, as you can see on the GIF there, and the core remains. If it is a really massive star, then that core becomes a black hole. However, after a supernova, it usually forms another very dense object, the strangest thing in the universe. It is called a neutron star, and if you want more information about that, I've made another video about that. Just click on the pop-out banner top right, you can watch that video. NASA have found at least 2,500 other star systems in the Milky Way. All of them are unique because there are some which have red dwarf stars, yellow dwarfs like the Sun, red giants, and more. The largest known star in the universe is UY Scuti, which is a red hypergiant. The smallest known star is EBLM J0555-57AB, which is part of a triple star system, which is 3 stars orbiting each other. My next video will probably be about UY Scuti or that really small one. So vote in the comments below. I will post 2 comments there, and then you just have to like each whichever one you want. Hope you enjoyed this video. If you did, please like it. Subscribe to this channel by clicking on the bottom right icon, and as I said, please comment about about whether you have any softwares that I could use that are much better than PowerPoint, or and which video I should do next.